All right, let's continue on with all the different identities and put it into one place. So we went through the different reciprocal identities and quotient and so forth. So let's just list them. We have, starting off here, is cosecant theta is going to equal 1 over sine theta. Then we have secant theta equals 1 over cosine theta. And then cotangent theta equals 1 over tangent theta. And we went over those already in the prior video. And then we also discussed our quotient identities. So let's look at those. This is tangent theta is the same as sine theta over cosine theta. And then the other one was cotangent. So cotangent theta equals the flip side, or the reciprocal is cosine over sine of theta. And then the Pythagorean identities. Those are the fun ones where we have like the unit circle, and we have cosine squared theta plus sine squared theta equals 1. We had 1 plus tangent squared theta equals secant squared theta. And then the other one was cotangent squared theta plus 1 equals cosecant squared theta. And the nice thing about these identities is you could just take that original one and create these others too. So if you don't memorize it, you can at least derive it and have it available to you when you're doing your problems. Now, trig is used in various areas of calculus. So it is, as it indicates, often necessary to deal with expressions that involve trig functions. Some of those expressions start out looking fairly complicated, but it is often possible to use identities along with algebraic techniques, factoring or combining fractions over a common denominator, to simplify the expressions before dealing with them. The goal for simplifying is to get a numeric value or a single trigonomic expression. So that's normally the goal. And we get to practice a little bit of simplifying using identities. And to me, it's like a puzzle. I absolutely love doing these. So let's look at the first example. Let me move this up. Thank you. So starting off with the first one, my first go-to is, these two things are side by side. That means they are being multiplied, either dot or you can put parentheses. They are being multiplied together. Well, sometimes it's easier just to switch it back to sines and cosines to see what do I have. Well, cosecant by definition is 1 over sine theta. And then tangent, remember this is being multiplied, is sine over cosine. Well, super nice, because now, just like if this is 1 over 2 and then 2 over 3, I can simplify. Sine divided by sine is 1. Anything divided by itself is 1. So now just multiply straight across. I have 1 times 1, which is 1, over cosine theta. And normally I'd say, oh, I'm done. But did I start in sine or cosine? No, I started in cosecant and tangent. That means I need the other format. So change that back. That's the same as saying secant. So if I'm not in sine or cosine to start with, and I end in that, I go back to the other form. And that's my final answer. That's reduced down to 1. Now, let's do the next one. This is all being side by side. So it's the same as, again, if you just want to make lines, that's where it multiplies. So looking at that, I have a sine and a cosine and then a secant. Well, let's change secant into its other format. Secant is the same as 1 over cosine x times, I'll leave cosine x as it is. That's the same as saying it's over 1 times sine x over 1. Okay, well, you can see that I have in the numerator cosine x, in the denominator cosine x. Anything divided by itself is 1. Straight across, I have 1 times sine x. That gives me sine x. And over 1 times 1, which is 1. So I don't have to put that because sine x divided by 1 is just sine x. And then let's go back to this one. Well, this is just rearranged. Let's look, let me pull down here for my identities. Look, this is secant squared minus tangent squared. Isn't that the same as if I move this over, secant squared minus tangent squared would equal just plain old 1? Well, there it is. I used my identity, and there is 1. That's all it is, because I have a Pythagorean identity that says secant squared theta minus tangent squared theta is just 1. Now, let's think about factoring out. Notice that this was all multiplication. This was an identity we already had, so I don't need to factor anything. But what if I do need to factor? So let's look at that. You can see I have a cube, sine cubed. I have a sine and then a cosine squared. These two things are being multiplied. It's just like saying x cubed plus 2x, and I'm going to take out my x. Well, they both have in common, you can see they both have in common between this addition sign of a sine. So factor out sine x. If I factor out sine x, I would have sine squared x plus cosine squared x. And if you're not terribly sure if you did it right, well, then multiply back in. If sine times sine squared, well, that's an exponent. We add exponents when we multiply. That would give me sine cubed. And then sine x times cosine squared is just sine x cosine squared x. And that's what the second item is, excuse me. Now remember what this is. Right here. This is a Pythagorean identity. And it's up at the top, or if you remember the unit circle, sine squared x or cosine squared x plus sine squared x equals 1. It doesn't matter if cosine comes first or second when you're adding, as long as they're what they should be. So that's the same as saying 1. So I would have sine x times 1. Well, that would just give me my final solution of just plain old sine x. It looks like it was going to be absolutely horrible, but it's not as bad as it seems. Again, if there's an addition, if I can factor something out, if it has a cubic or to the power 4 or any of those, you might be able to take a sine squared out, a sine, or whichever, because our identities are in singles or in squares at the moment. So we want to get it down to one of those two so we can then use our various identities to simplify. Hope that helps. These are fun.